someone from Australia, and she will be very happy.
All right.
No problem, no problem. That's useful. Yeah.
So yeah, we are happy to welcome Massimo, who is now Massimo Stella, who is associate professor in University of Exeter. He has really a lot of experience of working in different fields. I mean, like physics, right? Interdisciplinary projects. So it's really relevant. I think that we listen to his ideas and his projects. And he collaborated with, I think, all around the globe, with people from all around the world. And we met in the summer school, which was winter actually, it was winter school, but it was related to the Santa Fe summer school. So Massimo was kind of the person who also kind of introduced me to this community of complex system scientists who actually initiated that. So Chaklesh, for example, he was the right, you were also in 2015. Yeah, so like we have some people here who also have, you may have interacted. So floor is yours. Floor is yours.
Well, fantastic. Thank you. Thank you so much for inviting me. Also, this is a very nice initiative. As I was saying before, it's important that given the difficult time, we come up together, we share our mutual scientific interests, and this is a great initiative. I'm really happy to be here. And I will be talking about cognitive network science as a proxy for accessing key ideas and emotions in people's minds. And when I talk about ideas and emotions, these are aspects of knowledge. So that I would like to start by asking, actually, what is actually knowledge? In data science, we could say that knowledge is like data that we gather about the world. And this is a somewhat working definition. Let's make an example. We have a collection of documents, for instance, as our starting data. We want to extract knowledge from them. We do some analysis and we come up with a word cloud, for instance, as reported here. The problem with this approach is that, okay, we do some analysis, we have some results. So what? What are the cognitive, what does it mean to get central words, or what does it mean to analyze the text in a certain way? My approach is a little bit different. My research brings to the table of knowledge extraction and understanding the cognitive aspect. So that to me, knowledge is a mental representation that we build of our world via data. We need to consider that the data that we analyze, the documents that we analyze, do come from another cognitive structure, that is our minds. And if we do so and merge together the data, the analysis, and the cognitive dimension, we can achieve new ways of understanding knowledge, of extracting knowledge, and so on. In fact, the cognitive dimension can bolster the interpretation of the results, which is an important challenge for today's approaches in data science about knowledge understanding. Also, driven by cognitive models, we can assess what's the influence the results we get have for human behavior or human dynamics. And at the methodological side also, if we integrate cognitive and data science together, then we can get inspiration from cognitive models to design new ways for new approaches for big data analytics, for exploring the knowledge and its structure. And exploring the structure of knowledge will be a little bit the leitmotif of this talk. When I talk about the cognitive dimension, bringing the cognitive dimension, what I'm really talking about is considering a system that is called mental lexicon. This mental lexicon is a dynamical structure. It's not really like a lexicon, like a dictionary. It's very, very much dynamical. And it's a cognitive system that arises from the circuits of the human brain. It's made of idealized concepts or ideas. And we know very well that ideas and concepts can be similar or dissimilar with each other. So that we can also say that the mental lexicon has its own conceptual structure in terms of conceptual associations between ideas. And decades of research in psychology and psycholinguistics has shown that the structure of this mental lexicon relates to linguistic knowledge. And I encourage for you to actually read these two books because they're really, really interesting. And in general, we might say that this mental lexicon is a cognitive system that is apt at acquiring, storing, processing, and producing language. So we are actually using the system, the mental lexicon, because I'm producing words in a speech in order to convey a certain meaning. And you are also using your mental lexicon in order to identify the words that you are listening, what's their meaning, and reconstruct, again, the ideas that we are communicating with each other. So the mental lexicon is definitely there. It's very powerful, but unfortunately, we cannot bring it to the lab and tinker with it as we would with a human brain. Because the mental lexicon is an idealized system, so we cannot access ideas in a lab, or can we? What we can do is access a certain representation of conceptual associations and then explore the structure of this representation, which in the end, again, is the structure of knowledge that we want to investigate. And we can do so, I'm talking about structure, knowledge. So what we can really try to do is building complex network representations of knowledge in the mental lexicon in terms of associations between concepts. An example, when we read sentences, when we read language, we do not see the structure of conceptual associations, how concepts are syntactically related with each other in order to specify the meaning that we want to convey. For instance, if we read the sentence, failure and success are both sides of the same coin, learn how to face failure, we are actually connecting concepts together. We are specifying that failure and success are sides of the same coin. So we are intrinsically accessing these conceptual associations from language, from the knowledge as written in the sentence, without specifically seeing this network of conceptual links. What if we actually can do that? What if we could extract that from a piece of text or from a corpus of text and then investigate it? And also not only stop at the level of conceptual associations, but also consider how these concepts are emotionally perceived. If they are perceived as positive concepts, as negative concepts, or as neutral concepts. And in my paper, the last one about Mentis networks published in PeerJ Computer Science, what I did was use a machine learning predictor of syntactic relationships trained on a language model of millions and millions of English sentences. This machine learning model was capable of detecting syntactic relationships between concepts in sentences. And then I merged this with with a knowledge graph called WordNet, which contains information about which words overlap in meaning with other words. So considering syntactic links and synonym associations made it possible for me to represent a sentence as a complex network made of concepts interconnected with each other. In here on the right, I'm producing like the representation as a multiplex network. On the left, I'm putting the aggregate all together. Concepts are also attributed a sentiment score, a perception score. They are in red if they are negative, in blue if they are positive, in black if they are neutral. And positive, negative, and neutral come from a mega study in psycholinguistics about the way that one single large audience perceives concepts in common language. Now, the merge of emotional perceptions and conceptual associations make it possible to represent the knowledge expressed in sentences, in text, as a complex network. And this has mainly two advantages. The first one is that if we keep the cognitive interpretation, we can apply network metrics for understanding how this knowledge is structured. And this is particularly powerful because there are like hundreds of measurements from network science. Once we validate them and we understand what's the cognitive interpretation of them, we can directly use them for assessing the structure of the knowledge that we want to investigate.
Massimo,
And more,
we have one question actually.
Yes.
Yeah.
But how do you define concepts in the first place? Is it like tags on Wikipedia or?
Yeah, so concepts, they are essentially words that have been cleaned, so they have been stamped, for instance, so that their suffixes don't make like a change. And they need to represent a certain unit of language with a given meaning. For instance, a connector word like and doesn't have any meaning by itself. Whereas instead nouns like failure and success, they do have meanings. So this is the definition of concepts in this case.
So basically any word in your article or in your discourse or in anything?
Any word that, yes, any word that contains information by itself becomes a node of the network.
Okay.
Okay.
Thank you.
Okay. And that's a very good question. Also because consider, however, that unfortunately some words like not might not have meaning by themselves, but in this case, it's still good to count them because not is a meaning negator. So it's important to consider in a document which words are actually linked to not. And in fact, in some of the networks, you will see that I counted also not as a word. Okay, so there is an exception to this rule. But like what I was talking about previously, okay, this cognitive interpretation is important. We stressed it quite a lot in the beginning. And it's important, especially because it can then enable for us to reconstruct semantic frames. According to semantic frame theory, each event has a set of words that are linked to it. And the associations that we make in language between words end up casting meaning and emotions towards that given event. So in the case of a complex network, if we consider one word and we consider its neighbors, we could say that the neighbors constitute the semantic frame of associated concepts that end up providing information on the original meaning itself. And this identification of a semantic frame is particularly interesting because it then enables the giving focus to specific aspects of knowledge and see how they are associated in their own neighborhoods. But let me give you like a visual representation of this. And with an example, with a case study, I investigated 10,000 tweets about the gender gap in science. And the main idea is that each user on Twitter has their own mental lexica. They access their own knowledge in order to produce language. And in this case, language is contained in tweets. So it's a collection of sentences. It can also be emojis, for instance, and other types of information. So that's another exception to the previous rule, but because also emojis can bring information, semantic information. What's important is that we processed these sentences, we extracted the networks out of them, and then we aggregated them all together in order to have a network representation of the knowledge discussed in tweets. So this network representation represented how the online social users discussed the theme of the gender gap in science on Twitter. On this network, you can see that there are words, and then there are also associates to these words. Because of what we said with semantic frame theory, the associates of a word end up casting meaning and emotions onto it. And the idea is that this is contextual knowledge, so that even though one word, for instance, might be perceived as neutral in language, in the specific language investigated here, this word would be associated with so many other positive words that it would end up acquiring a positive connotation, a positive context. I call this positive emotional aura. And this effect definitely comes out from the network structure. This is not something that we could compute if we didn't have a look at the actual network. And I will get back to these ideas of emotional auras immediately, because I will give you an example of the semantic frame of the concept of woman as discussed in this social discourse. In here, I'm producing also a visualization with communities based on the Lowen algorithm, so that you see these clusters here. And we notice that immediately, by visual representation, we notice that the social discourse framed the concept of woman in a generally positive way, rich in positively perceived words, and however, within the community of more tightly interconnected concepts that are closer to woman, we notice also negative associations, like kill, woman, oppressor, woman, shot, indebted, lone, and cry, which are indicative of negative perceptions that are indeed the outcome of stereotypical perceptions around women in science and issues that women have to face because of the gender gap. So notice that in comparison to a social discourse of 10,000 tweets, we extracted, by considering the conceptual structure of knowledge, we extracted immediately very simple information that can tell us that the way that users discussed and perceived women with their own language was mostly positive, but it still featured stereotypical perceptions, which should be taken into account when designing potential intervention policies. Also, it's interesting to do, well, there is a question. So I'm like time the presentation so that I talk for 30 minutes. But if you want, I can continue with the presentation and we can end and have all the questions at the end, or I can do online, whichever you prefer.
I think let's take the question because it's kind of on something maybe that is useful right now. And if you don't mind, is it fine for you?
Of course. It will just take a little bit longer than 30 minutes.
It's fine.
It's fine. So the question is from Lionel: in the emotional model you're using, which are positive and which are negative? The words are defined as positive and negative according to scores, balance scores, that were produced by another mega study, which rated 13,000 English words in a population of like a few hundreds of individuals. So, and words were introduced or like tested individually without a certain context. So that the outcomes that you see here are the definitions of one single general community of people that were asked to rate positive and negative concepts in common language. Okay. In the second part of the talk, I will talk about another way for deciding which words are positive and negative according to specific groups and specific context, and we will see that there will be also some differences. Can I continue? I hope this solves the question. Okay. And well, but like, you know, positive and negative in the end is not that interesting, because yeah, we can say fantastic. The social discourse was overwhelmingly positive. But if we check the semantic content of these positive words, some of them celebrate the career, some others relate to the future: will, let, want, like, support, and so on. So what about the different dimensions, the cognitive emotional dimensions that were at play here? By featuring this semantic frame, we can investigate what's the richness of words that elicited a certain emotion in the semantic frame compared to random expectation. And this is what I'm trying to visualize here. This is a visualization that I introduced and called an emotional flower, where each petal is a Z-score that comes from the richness of words in the empirical semantic frame against random expectation. And in here, I'm using the dataset of the emotion lexicon by Mohammad and Turney, so that it gives information about 8 basic emotions. And we see with these emotions, for instance, that the way the women were perceived in social discourse was by considering overwhelmingly positive emotions like joy and trust, but also by projecting the idea of woman into the future, because anticipation is an emotion that calls for future endeavors. And this is confirmed by the semantic analysis of this content. So indeed, positive perception, but also aimed towards the future and improving the future. Okay, and I used these types of textual Mentis networks for investigating also the perception of the COVID-19. In particular, on March 11, the WHO declared COVID-19 a pandemic. They gave a speech that was broadcast all over the world, And several news media reproduced and reframed these news. Also, the social media reacted to this and discussed the concept of the pandemic. So that in my very recent, very little, small exploratory study published on systems, I investigated the semantic frames of pandemic in the WHO declaration across a few medias and across social media. And I found that the WHO actually reported the concept of the pandemic as a concept almost free of emotions. The only emotion that was stronger than random expectation was fear, and in a moderate level. So a moderate fear is actually concern. And in fact, if we see the semantic associates, we notice that the WHO presented the pandemic as something concerning, a concerning phenomenon that we need to control, we need to mitigate. So they try to really explain what was going on. The news media did not produce the same semantic frame. Unfortunately, some boosted the anticipation into the future combined with fear, so indicating a preoccupation, like a concern for the future. And others instead, they did the opposite. So they tried to channel the concept of the pandemic in a semantic frame related to almost neutral concepts related to change. We need to change, we need to count, the pandemic will change our society, we need to count, we need to use science for understanding how it will change. And they enabled a semantic frame very rich in terms of trust. The social media, instead, presented a much more complex semantic frame. This is expected because this is a collection of 37,500 tweets, so much more information compared to single speeches or news articles. However, this calls for the idea that the concept is the same, so pandemic is the same. If we do simplistic analysis like counting the frequency of just one word in tweets, we will probably lose a lot about the information of the knowledge surrounding that word that can be captured instead by considering a network structure. And in this case, it was evident that pandemic elicited positive concepts clustered together about being aware, needing help, and so on, but also negative concepts about being attacked, about the need to be not inside, to be not left alone, to act for intervention policies. So future research should definitely keep into account the richness of linguistic information that is present in social media information rather than in simple news and news outlets. Notice that the same news was perceived very differently across different sources. So we definitely need new ways of keeping into account how the same news is framed and reshared across information channels. I also use the same structure, the same methodology for investigating social media discourse after the reopening on May 4. Italy released the first lockdown after almost 3 months of national closure. It's really a shame that now we are in a totally different situation. But this analysis investigated how Italians discuss the reopening online over a collection of 400,000 Italian tweets. And I found several things. I encourage for you to read and give me feedback about this publication on first Monday. A few interesting results are that these Formae Mentis networks have enough resolution power for understanding that emotions over social media are volatile and for showing it quantitatively. For instance, this is the semantic frame of quarantine, right before the lockdown and right after the lockdown. Right after the lockdown, we were quite unlucky. We had a few cases of contagions that were boosted by the news media, and they created panic all over the information channels. And this is evident from the semantic frame. Before the lockdown, the quarantine was seen as a concept eliciting anticipation, trust, and a little bit of surprise what will happen in the future. After the lockdown, because of these issues, of these cases, all these emotions vanished and they were replaced by a sense of sadness. So this is again important. When we do studies on social media, the emotions that we investigate might not be stable over time. They might change over even a few days. And we definitely need a higher resolution power in order to understand where do these emotions come from. If we consider the semantic frame here, if we read the cases, you will see that there is lots of jargon related to cases, contagion, and so on. And another interesting result was seeing how these flickering emotions, they surrounded the discourse around politics and institutions. In a period of crisis like a COVID pandemic, like the COVID pandemic, trust in the institutions is particularly important. Again, remember we said we bring the cognitive dimension into our analysis because it will help us. And detecting trust in this case, we know from cognitive science that trust is an important mechanism, cognitive trust is an important mechanism for people to reason and give reliability to other agents and follow the rules that these other agents like governments and institutions impose to the citizens in order for them to be healthy. What happens if this trust disappears? Social riots, social issues, problems, and so on. So the question of being able to monitor the levels of trust in politicians, in institutions, and so on through social media is particularly important under a time of crisis. And notice that in my analysis, although the trust persisted before and after the lockdown in Italy, we had problems with the reopening because the legislation was not very clear about the ways that different businesses had to reopen. And this was reflected on social media because emotions like anger and sadness became stronger after the release of the lockdown. Contrary to what we would expect in general, oh my God, it's the end of a lockdown, everything will be an happy ending. No, it's not. And we need the power to isolate specific semantic frames, like we're doing here with Mentis networks, in order to really detect these trends. Okay, so this was the part about the COVID-19. Now, in the last few minutes, I would like to talk a little bit about the educational implications of these Mentis networks. And I will do this in a little bit more interactive way so that we put different STEM subjects on the line, like in that movie, The Usual Suspects, and we will try to see how different populations perceive STEM subjects. Let me introduce you to Mike. He's a high school student. You see him smiling over books in a library, and Mike says that he never understood science and he's quite proud of it. This is a quite concerning negative attitude of closure towards science. Not only students end up not understanding it, but they're also happy that they don't understand it. This is quite concerning. How can we access students' minds? How can we enter in their minds and try to see what's the structure of knowledge that surrounds these negative attitude? So notice again how the emotions and the knowledge, the semantic content, are extremely important and integrated with each other. In our minds, emotions and knowledge and memories and linguistic content are not really that far apart. And in psycholinguistics, there is even more and more attention that is being devoted to emotions and emotional perceptions, even when we process domain knowledge or specific expertise knowledge. Okay, in here, what we did, this was in 2019 with my collaborators, Sara De Nigris, Alexandra Alorich, and Cynthia Sue, was propose a different type of Mentis networks based on behavioral experiments. In these networks, again, nodes are concepts, but links indicate memory recall patterns that I will be talking about in 1 second. And emotional perceptions in this case are attributed by individuals. So we asked for individuals to read a concept and say, is it positive for you? Is it negative? Is it neutral? Rate this. So that with this approach, the perceptions that we came out with could be different for the same concept rated by different populations. Whereas you remember in the text processing, we had to stick to one emotional perceptions as in common language and then use the network associations in order to really cast meaning into that concept. In this case, the links come from the free associations test. It's very simple. Let's make an example, an exercise here. So tell me what is the first word that comes to your mind when you read complex. First word, without thinking, complex.
Wait, I'm unmuting. Okay, go for it. Networks, what else? Systems.
Very good.
Network.
We have also one in the chat.
Emergence.
Network, cool, simple, very good, perfect. Brain, very good. So you see, you need to do this immediately without thinking. This is free from any definition. This is actually a very powerful technique. It comes from psychology. It was even used by Freud in the beginning, but then psycholinguists used it for a variety of reasons, because these free associations are actually memory recall patterns. They are shortcuts between concepts that come from our semantic memory. They are indicative of the way the knowledge is organized in order to be quickly retrieved in case of need. The structure of free associations over the last 10 years have been used in several data science studies for a variety of problems, and has been quite successful and powerful. I'm talking about problems like identification of memory patterns, predicting early word learning, identifying creativity levels, like distinguishing highly creative from lowly creative people, identifying authors and writing styles in novels, in large corpora novels, and even predicting cognitive decline in people with language impairments. Free association networks were extremely useful for all these tasks and even more. And this is what we used for these types of behavioral Formae Mentis networks. We asked for two populations to provide free associations and emotional perceptions. High school students from Italy and early stage researchers from the Winter Workshop on Complex Systems. So basically, PhD students, postdocs, and a few people more advanced than that, all working in STEM, so being STEM professionals. And a first result that we had was that in both the networks, concepts that were negatively perceived and were also surrounded by a negative emotional aura, like in here, they identified with a higher intensity emotions of anxiety compared to negative words that were not surrounded by a negative emotional aura. So the surrounding of negative emotions, again, casts meaning and emotions onto the original word, which ends up being perceived as an anxious concept. And this we did with a cross-validation with another data set from an independent study. And it will be useful right now. So let's do, like in that movie, the usual suspects. Let's put the different subjects of STEM in comparison. Let's see how different groups perceive them. For instance, for mathematics, professionals perceive mathematics as a positive concept surrounded mostly by positive or neutral concepts. What about students? What do you think that students, how do you think the students perceive the mathematics?
They all love it.
They all love it. Very good. Very good indeed. Unfortunately, they perceived it. Remember, I told you, now in this type of Formae Mentis networks, behavioral Formae Mentis networks, the same concept can be emotionally perceived differently according to the population that you ask to. And in fact, mathematics was negatively perceived by students and also surrounded by an emotional aura of negativity, which is an indicator of mathematics inducing anxiety in students because of the results that I told you about previously. Let's do this also for physics. Positively perceived in STEM professionals, related also to model, theory, nature, with strong connections, with strong conceptual associations. What do you think it will be the case for students, for high school students? Take your chances.
Generally negative.
Generally negative, and this is it. It's exactly like this. It's perceived as negative, which is concerning, surrounded by a negative aura, but in this case, there is a positive cluster of positive associations. And for the Italian speakers among you, you will see that these clusters, they relate to science and lab experiments. So that the students perceive physics in general as negative, but when they think about experiments, they have a good perception, a positive perception. What about science? For professionals, this is almost like, I mean, it's good. It's a positive perception in their mindset, in their global mindset. What about students? What do you think that it will be the case for students?
I would guess about even.
Even, okay. In the room, like in the people in the room, is the same, the even split, 50-50?
Are more for positive.
Okay.
Positive.
Well, you will see that for students, science was a positive concept surrounded by a mostly positive emotional aura / neutral. The only two outliers, the only two negative concepts were mathematics and physics. So students were capable of recollecting in their memory, in their semantic memory, that mathematics and physics are related to science, but they were unable to transfer their positive perception of science onto the perception of the building blocks of science, like mathematics and physics. So this is a problem. This is an indication of a dissonant cognitive perception of these subjects that we identified with Formae Mentis networks. And not only this, Formae Mentis networks, remember, give access to the semantic frame that people associate and attribute. So this is the way that people perceive these subjects in their own minds, the main ideas that they associate when they think of these subjects, when they perceive these subjects. And we notice that in the semantic frame of mathematics in students, all these negative associations are actually ways of doing computation. Students are lacking why they are doing mathematics, why they are doing computations. They're extremely good in recalling the jargon, the domain knowledge of, okay, mathematics, graph domain, metric, median, blah, blah, blah. But they don't really make associations like mathematics or physics, like mathematics and the investigation of reality, mathematics and nice. So they are a little bit limited in their understanding of what's the aim of mathematics and what's the beauty of it. And also what's the creative process that relates mathematics and physics with creativity and creative discovery of the real world. And this is particularly concerning. Students are lacking conceptual associations that researchers have about physics and adventure, art and data, science and fun. So this is quite a problem, and we should try to use the Formae Mentis network of researchers that we are capable, that we mapped via Formae Mentis networks in order to improve also the mindset of students. And in another paper with Anastasia Capuzza, Catherine Kramer, and Steven Uzzo, we tried to understand whether this negative perception was due to a lack of computational thinking. And we found several signs that in the students, unfortunately, concepts related to computation, modeling, data, they lack the semantic frame and awareness about simulations and being tools for researching and discovering the world surrounding us. For instance, in here, like the semantic frame of model was strongly related to fashion, photography, and so on, and very weakly with scientific concepts in the students' minds, whereas in researchers, model was strongly, tightly interconnected with research, physics, computer, and so on. So we should, yeah, we have a question. How did you classify positive and negative words across the two samples? Because I saw that, for instance, in the professionals network for science, mathematics was positive words. Exactly, yes, exactly. So that's exactly the point. So we asked for each student to rank mathematics on a scale from 1 to 5, where 1 is negative concept, very negative, and 5 is positive concept. And we did it for all the 159 students that talked about, that considered mathematics in their own experiments. Then we asked separately for the researchers to do the same. We came up with two distributions of scores that provided by statistical comparison these two different labels. So the same concept in these Formae Mentis networks, the behavioral Formae Mentis networks, can be emotionally perceived in different ways. in the textual processing from Mentis networks, we didn't have human subjects to enroll in an experiment. That was just text processing. So we used the data from a previous experiment that was indicative of the way that one single population perceived words in language.
So I have a question also, Massimo, because here you obviously you aggregate results across two populations and show average results. But in a way, one population is kind of homogeneous. It's basically the one who had good grades when they were students in mathematics, and you select them and they're professionals, right? And obviously they will be happy doing that because that's why they chose the job. And then there's a heterogeneous population of students with low grades and high grades. So are you, one question like devil's advocate, you know, are you just showing that if you are graded on something, you don't like it? Or like if you were to take the subset of good grades students, would they be similar to the one that later on end up being professional? Or do you actually indeed show that this is about this kind of systematic effect that you're showing us right now? How do you?
This is a very, very good question. Absolutely, very, very good. The problem was that we didn't have access to the grades of the students because we didn't. That was a private data that we couldn't access for free. However, let me tell you, I didn't say this in the beginning, that these students, these high school students that we are considering, they were all in their final year of high school and of a specific type of high school, which was focused on the study of scientific disciplines. So already in Italy, like students can choose which school they can enroll with, and all of the students reported here were so-called like experts among high schoolers in terms of studying scientific disciplines. So this is already like an indication that the students that we're reporting here should be already like in good tune with the disciplines. Then of course it's difficult because there might be better performing students and less better performing students. But also this could also be true on the other side, because it's not always the case that researchers and professionals, they were good at maths during high school and they ended up being good at maths in their work. Also, the experts, the PhD students, they were not only physicists. They were biologists, chemists, they were also from the humanities, from the social sciences, from psychology. So also other type of disciplines that were a little bit less homogeneous, let's say. But it would be interesting for future research to show how these scores, like how the distribution of these scores is related. What I did in here was just a check that unfortunately, the distribution of scores for most of the concepts in the Formae Mentis networks, they satisfy the Kolmogorov-Smirnov test, which indicates that actually the scores that we see are more related to a bell than like two different lumps. So I used that as an indication that the results were quite homogeneous, but it would be definitely interesting in future to try and see if there are maybe smaller differences or maybe like differences in other semantic frames between better performing students and less performing students. That's a very good point. It's just that the evidence that I gathered here was really not enough to make these claims.
There is also a question from Stephanie.
Yeah, a question on the screen. Sorry, I did not get how a negative word can have a positive aura. Isn't the negativity of a word in its semantic meaning? Very good question. No, unfortunately not, because language can also be contrastive. So we can contrast one thing with other things that have the opposite meaning. Or we might have a negative experience, usually it's the opposite, like a positive experience that reminds of ourselves of other negative experiences, because we tend to contrast concepts. We can say one thing is better than another one. For instance, imagine like doctors. Doctors by themselves, they are a positive concept, but doctors in general work in hospitals, work with sick people, work with sickness. So when we think of doctors, we might have a positive concept that is associated with a variety of negative concepts. So it can be the case also that a word by itself has a certain meaning, but then again, in the specific language that it's used or in the specific context that it's used, it acquires a certain different meaning. So it's important to consider always not only the word by itself, but also the network structure around the word.
Yeah, because then
Okay.
maybe it would be easier to consider a word as a simplex, not as a point, but something like a context. I don't know if you have ways to present.
Exactly. So this is another pattern of complexity, that language has structure, knowledge has structure. It's not just a list of words. Words are not independent from each other. We definitely need to keep into account this structure of knowledge in order to better understand it. And so if I can just finish, because I'm almost done with my timing. In here, what we need to do is try and repair this cognitive dissonance of students, of high school students, studying a lot of mathematical disciplines. And you see also that these are expert students, because you see that they can associate so many different jargons, so many different terminologies with mathematics and physics. You have like Kirchhoff law, electricity model, the universe, and some graphs, limits, and so on. So very good knowledge. But when we consider the emotional dimension of knowledge, we don't want to end up with students that are capable of doing tasks, but dislike or hate doing these tasks. So this is something that should be considered in educational systems, and something that can be highlighted by considering Forma Mentis networks. And we also would like, ideally, to make high school students already as positive about sciences like physics and mathematics as experts are. We could use the mindset of researchers as an inspiration, as a grounding for, as a starting data for future endeavors in improving this perception. Okay, and I'm done. Thank you so much for your attention. Just a shameful advertisement. There will be a satellite at the Conference on Complex Systems 2020 about complexity and cognition, where the scientific committee of different professors from the US and from all over the world will be talking about their research. And there is also the possibility for participants to showcase and give a talk about their own research. So please have a look and see if this is of interest to you. Thank you.
Thanks a lot, Massimo. Beautiful, beautiful talk. I actually have one general question, and I want to play a bit the devil's advocate here. So if I see, so apart from the beautiful visualization that you show us with the network, one of the main use you do is the kind of transfer, the network transfers that you operate, right? It's kind of like a process where you would transfer some balance or some meaning across, or some sentiment across the network. Now that's in a way, I could just do data science and say, if you're in the same sentence and another bunch of words, you just transfer from this process, and that would be the same result. Now, if I think network, I want to see something, you know, where you show me that the degree or the betweenness is associated to something, right? That there's a structural difference, or maybe that the communities have a meaning that you wouldn't get through just natural descriptive statistics. Or maybe that's a path of, in one case, I'm 3 or 4 links away from something with good sentiment. In another one, the mean path is smaller. So have you operated this kind of more like the larger structural kind of insights, or is it the direction you're looking at?
Yeah, absolutely. So if I managed to go back, like, this is something that I did. So I tested what type of information could we use for Mentis networks, like for the text analysis, for seeing whether it was possible, for instance, to use Forma Mentis networks for doing the topic detection. So what I did in this paper here was building Forma Mentis networks, textual Forma Mentis networks for 10 short annotated paragraphs, for which the topic of the paragraph was present. And then I used conceptual distance, closeness, centrality on these Forma Mentis networks in order to detect the top ranked concepts in these networks, and see if these top ranked concepts were semantically related to the general scope of the paragraph. And across all the 10 cases, I found that the network structure of syntactic associations and synonyms was indicative of the top ranked concepts that were related to the topic. So it was possible to use these types of textual networks for extracting the information of the topic, what was that short text about. This is a test that I did in this experiment here. I also, in the other paper about the social discourse, I checked how closeness centrality again was related. Well, in this one, I checked how closeness centrality was related with the frequency, for seeing if like frequency captured different words compared to closeness centrality. Closeness centrality is important because on semantic networks, closeness is a good estimator for semantic relatedness between concepts. And it even outdoes other ways of computing semantic relatedness like latent semantic analysis. So these kinds of networks are quite interesting. And I found out that in this data set, frequency was capturing words of protest, of social denouns, whereas closeness was capturing hopeful concepts. Unfortunately, I didn't have time to like space in a paper to really dig into that. But my indication is that we need both of them if we want to do like basic word level analysis, because like frequency can give an indication of how frequently users are exposed to a certain concept when they read their flow of tweets. But closeness gives an indication of how central a given concept is in the layout of all different semantic frames. So it gives an indication of how important that given topic is for the general discussion, independently on how many times you read the flow. So that's also another indication, some other space. I think this calls for future research for understanding a bit better what's the implication, as you said, when I do data science. Okay, so what? It's important to see, okay, what's the implication if we, for instance, influence users and we feed them for central, like closeness centrality, concepts that are highly in closeness centrality and concepts that are in frequency. Can we influence users now in different ways? Or can we promote certain emotions better with closeness and better with frequency? I think these are all very interesting research questions that we should try to tackle and see and play a bit and see how it looks like.
So I saw a lot of people happy in the audience.
Okay, sorry.
Any, like, I open the floor for any other question that you might want.
There is a question.
Yeah, if I can do a question.
Go ahead.
Okay.
Sure.
Thank you, Massimo, for the great talk. Really great. So I had somehow two related questions on the talk, and one was that so the difference that you observed in the formative network between the high school student and the professional is somehow, if you check or you have other data to check, if somehow this difference is actually related to the educational levels of these two, samples, because I expected, of course, as you increase into your educational level, so let's say from a high school to a PhD, to having a degree and then a PhD, this kind of let's say positive, from negative to positive, will actually change. And the second question is more or less used, let's say, so you have shown that basically, at least it's related to somehow the other question, which is so the formal Mentis network in principle could be used to track or to assess the progress of a certain topic over time, for instance, in high school education. Do you know if there are any studies about that, or your thought about it?
Yeah, thank you. Very interesting questions. Unfortunately, for me, it was a bit difficult to track like students. I think like one way of answering to the first question would be to track the same cohort of people and see over time, like when they transition from high school up to the PhD, how do they change their perception? I'm like writing grants right now for trying to do on a shorter time scale, like before and after a course, and see if the same population changes their own perceptions about some things, according to the intervention, which in this case is the teaching. So for instance, if teaching is effective in improving the perception the students have about mathematics, if we already warn the teacher that you might want to try this, this and that, or if we don't, and see in these two cases what happens if there are changes or differences. But I did something similar like this. So about the second question, keeping track of the changes of mindset over time, I did this for a consulting in Norway when I was a consultant. And we did this before and after in a small class of students from engineering and nursing about e-health. They had to build a robot essentially that was supposed to help people with the hospitals. And before and after the intervention of 3 months, it was a training on campus for 3 months. All the students improved their perception of technology and innovation. We checked the semantic frames of these concepts. And also, interestingly, they developed quite a lot soft skills, their soft skills, like working together, collaboration, and so on. So the experience had an impact in their Forma Mentis, both at the level of the whole group and at the level of the single individuals. Almost on all of them, we noticed these changes. And it was possible to highlight this with a Forma Mentis network. So we are now interested in understanding if this can scale up and if we can use it also as a predictor. Like, for instance, if somebody has a starting Forma Mentis network, can we predict how they will behave in a certain exam or in a certain training course? Or can we design some strategies for improving the learning experience based on their Forma Mentis networks? This is something that we are trying to get funding for. This is something that we are trying to do. Work in progress, let's say. But it's quite interesting because in this way, we don't need for people to make exams, or we can have people like making exams on one direction, but also we can test their emotional perception and see if there are improvements and changes. This is something that is quite interesting.
Yeah, thank you very much.
Thank you, Andrea.
Thank you.
Okay.
We're approaching the end, but I just wanted to ask, because I have the opportunity to talk to you, to ask you maybe your opinion on like another question. In a way, what you're showing us, what I like with this approach is that it shows a bit also the way to systematize thinking, especially with what you have shown with the model, kind of, and you show this density of this network that increases. And something that I've noticed, like there's kind of a certain mindset that goes into being an interdisciplinary human being, and especially here at the Center for Interdisciplinarity, we have these people that have this systems thinking. It's something that really characterizes them, that they make associations all the time with anything. And it seems to me that would be almost like a personality type we would see in your network that are like literally all over the place connecting everything, and others that are maybe more specialized. And well, obviously you said that people were kind of monomodal. Systematicity, thank you.
Yeah.
But it seems to me that would be maybe on a larger set, a bimodality in a way appearing, or is this something you've seen or you've thought about, or?
I think this is a great question again, because it really resonates with also my experience as well. And I think like there is the problem with psychology and with the cognitive science is that complex networks are quite old. Like they were introduced in psycholinguistics almost 50 years ago, but they were introduced only as qualitative tools. They were not really tested on large data sets. So they didn't work, and they were extremely criticized in the literature, so that people were really, really against the idea of using complex networks for representing the mental lexicon. Up until 10 years ago, Mike Vitevich and Steven Tenenbaum and other cognitive scientists rediscovered the concepts of complex networks because of the complex network explosion, let's say. So I think like the idea of characterizing people's mindsets in terms of different complex networks is now something that we are seeing a little bit more commonly. But still, I think like your idea relates to this polymathy, which is a feature of people. It's a personality trait. Polymathy is the ability for people to encapsulate knowledge from different areas all together, but also to be systematically good in each one. And so that they can see concepts that are distant apart, but in their own mindset, these concepts are interconnected with each other. So they have these ideas of the shortest paths. They can make associations. So I think that this is definitely something that we will see in the future, and something that it's also possible to do right now. It will be very interesting to check like how researchers that are in an interdisciplinary environment compared to another control group that is made of researchers like standard, let's say, or all type researchers, to see how their Forma Mentis networks changed. If really these associations were possible or evident. This is something that we could really see, because we could represent, again, the mindset, the structure of knowledge in these people. This is something that we could do. I think there is positive evidence in the literature about polymathy and also creativity. In creativity, there is Mednick's theory, which is an indication that we can predict creativity also from language. Creative people in general are people that can have certain cognitive strategies that help them associating together concepts that are actually quite distant, quite far apart. So that they see a combination of concepts that to normal people doesn't appear, doesn't fire out.
Typical combinations, right?
Exactly. So it might be that also for interdisciplinary people, they are trained, so it's not like a personality trait. In their case, it's something that comes after training. They are trained to see problems in a certain way, to make connections. And we should be able also to use the same techniques from Mednick's theory in order to characterize this sort of interdisciplinary, which would be quite fun. It would be quite fun and quite useful also. Because I think like we need, in order to promote the funding for science and research in interdisciplinary systems, we need to display what's the advantage of having people being trained and educated in interdisciplinary sciences. And if we could show that like people can make creative links, they can really connect together elements from different silos, from different containers, this would, I guess, have a great impact over funding and over the next generation of scientists.
Awesome way to finish, actually.
Okay. So we need to work on this. Let's say it's a work in progress. Let's recognize this.
Massimo, thanks a lot for your talk.
Thank you so much for inviting me. Thank you so much for all the questions. I really enjoyed that.
Yes.
Thank you.
Wonderful, wonderful. Thank you.
And
Thank
the recording, I'll save that, and I'll let you know maybe if you agree that we can put it maybe.
Of course, I agree. I agree. It's perfect. Thank you so much.
Thanks a lot.
Okay, thank you. Have a good evening. Bye.